So we have a practice problem. We're just talking to the video now. We have a practice problem here. We've been working on it for a few minutes. It's been quite challenging, so I'll give a moment here. Now, are we ready to talk about it? Or do you need another moment? Or two even?
Yeah.
Okay, we'll give you a little bit more time to chew on that.
What does question G say?
So question G is saying for what values of x is p, and this is my symbol for increasing. So where is the function increasing?
Okay.
And then where is it decreasing?
Okay.
And
So
then we
we write like
said,
an inequality for that?
so right, so you can either, we're asking for x values,
Yeah.
so it's an interval, so you can either use inequalities or you can use that interval notation, either one's okay. And for the people there, and this is supposed to be 0, not O, although I will admit that that's hard to distinguish. If look inside my head. We had a great discussion, don't stop now.
Maybe negative infinity, like an inequality, negative infinity plus than or equal to x is equal to PD, right? For like increasing.
You're
Right?
supposed to respond to that. When the question is asked.
Going ahead and wrong.
Exactly.
Like, am I really wrong? Or? And then there would be a second one.
Yeah, so Q.
We ready yet to talk about it, or you still need a minute?
Oh, I completely skipped that. What?
Don't leave me hanging there, right?
New class model.
Okay, so let's start the discussion here anyway, or continue it. P of 0 is going to be what?
B.
B. Good. So this is the x coordinate. We want to find P of whatever is asking for a y value. And so at 0, we're right up here. So where the curve crosses the y-axis is at B. So that's going to be B. That seem reasonable? Okay, so if P of x is equal to A, what is the value of x? So here's where A is. And when you look, where does the curve have a y value of A? This is going to be the point where P, the function P of x is equal to A. We want the corresponding x value, so that's going to be m. So that's going to be x equals m. All right? Sage, we okay with that?
Yeah.
Okay. And now this is kind of tricky, is P of Q over 2 closer to B, the y value of B, or closer to 0? So now,
I said D.
okay, well, let's see. So Q is right here. So now you're going to have to use your estimation skills. I think Q over 2 is going to be somewhere in that neighborhood. And so P of that is going to be somewhere up there. So no matter where you may have picked, my Q over 2 may not be exactly right. But clearly the y value is going to be closer to B than it would be to 0.
That's what
So
I meant. I could really like verbalize it.
So we want B. Does it make sense, the reasoning behind that? Okay, is P a function of x? Yes or no?
Yes.
Yes. Why?
Because for every.
Good. Yeah, and that's a great one to use since we have the graph. Then appealing to the vertical line test is a great way to go. So we can try the vertical line test. It passes the vertical line test. Did we say anything different?
And so for every input, it gives one output.
And that's reasonable to say too, because that's correct. Yeah. So each input gets exactly one output. Okay. How about turn it around? Is x a function of P? No. Now, what's your justification there?
For every y input, or for some y inputs, there's multiple outputs.
Okay, or, yeah, so now you have to be careful how you say it, right? So for an input of, say, an input value that is a P value, say B, you could say there are multiple output values. Or did anybody else say it differently?
The H of P.
Yeah, you could say, since we have switched it around, this fails the horizontal line test. So it fails the horizontal line test, because there's a horizontal line that intersects the graph in more than one point. That okay? Anybody have anything different? Okay, good. For what values of x is p of x less than or equal to 0? So less than or equal to 0 is going to be the part of the curve that's below the x-axis. So this is the part of the curve that we are trying to reference. But we have to name it by an x value. So we have to give it in terms of inequalities or an interval notation. So are we going to include n or not?
Yes.
Yes, because of the or equal to. So there are a couple of ways you could do it. You could say x is less than or equal to n. That would certainly work. You could write this as a double inequality. Infinity is strictly less than x is less than or equal to n. Or you could do it in our interval notation, and you can't include infinity, and you go from small to big. So not including negative infinity, but including the n. So any of those three would be correct. Do not use words. Don't say, you know, I get this occasionally, left of n or something. Don't try to use words for it. It's got to be one of these three symbolic representations. Anything else is not going to be acceptable. It's not going to be correct. Okay? And for what values of x is p increasing? So here's where the curve is rising from left to right. So there's going to be two pieces of it, right? So now we're talking about all the way up to this point right here. And that is, I'm not trying to be tricky there. It may not look exactly that way, but that was intended to match up with p. So the x value p is going to be the peak of that curve. So for that part, you could say p is, I'm sorry, not p, but rather x is less than or equal to p. But then there's another part of it over here. And so we have to include that, so we use the word or. And then you could say, let's see, that's from q on. So for q, x rather, greater than or equal to q. So that would say, not and, because now here's the difference between and and or in math. And in math means to be a solution, it has to make both of these correct at the same time. So you would be saying we want all of the numbers that are left of p and at the same time right of q. Well, there aren't any numbers. So if that was an and, this would really be saying the empty set. There's nothing at all, which is not what we mean. An or means it can make either of these correct, and it's counted as being in that solution set, in that set. Either, and it could be both, but as long as it's in one or the other, it's in that set. So now we're including anything that's left of p together with anything that's right of q. And if they happen to overlap, which these don't, but if it happened to overlap, that would still be in there too. Okay, so this is tricky because conversationally, a lot of times we don't really say the right thing, but in the context of the conversation, we understand each other. In math, you can't leave it to, you know what I meant. So you have to say exactly what you mean. It has to be an or. Okay, so that's the increasing part, right? So that's where p is increasing, and it is decreasing when this thing is falling from left to right. And so that's going to be this part of it in there. That we can write as a double inequality. So p is decreasing on the interval from, where we go from pq. And do I include the p and the q or not? Is it or equal to or not?
Yeah.
Yeah, 50-50 chance on that one, right? Yes. So it seems weird when you're starting out, but hopefully it will become less weird as you get more comfortable with it. But those boundary points are included where it is increasing and also where it is decreasing. So it's an interval thing. So we're talking about the interval where it's increasing and the interval where it's decreasing, and the boundary point is part of both the increasing interval and the decreasing interval. Remember, our definition was if it's increasing, if as the x values increase, so do the y values. And q fits in with that. right? As these numbers, as these x values get bigger, so do the y values. It's decreasing if, as the x values increase, the y values decrease. And Q fits in with that description, so it also is a part of that decreasing part on the left. Questions on that? Tough? But fun? Challenging? Okay. I've got a feeling you might do something like that on the test, just a hunch. So let's talk about questions on the homework. Anything you would like to see done, clarified, explained? And as you're doing that, we're going to need our calculators a bunch today. So if you've got a graphing calculator, bust it out. If you don't, I've only got 2 rentals that are available. How many people do not have a calculator with them today? Raise your hand. Perfect. You can go, I'll grab one and throw it to you here. I got your batteries, but they froze all of our orders. We ordered batteries back in February, but with COVID and all that, they froze all the orders.
I have my own.
Yeah, so
I think Courtney was.
Colby, oh, that's a tough break. Can't give you that one.
I think
Let me
I'm
see.
gonna Filipino's room, I guess.
I might have one. I have some available for checking out.
I
You just don't know about the battery situation.
Did you get this from Gabe?
That's gonna be
You don't have
an
birthday
issue.
yet. Oh, yeah. That's actually my hotspot password. I know. Mine's all yours. Because I don't feel like remembering a password. Don't know any gold question mark? I have him as a drag queen on SNL. One more copy. This one got water.
Vino got some, you think?
I'm gonna be a Democrat.
Do you have a graphing calculator I can borrow? We are battery depleted over on my side.
I'm very uncomfortable with the atmosphere we've created in the studio today.
And you gotta remember, I gotta give this back to Mr. Vino. Anybody else not have a calculator? Okay, questions on the homework? Yes, Katrina.
Last night's homework, 23B.
23B.
The whole of 23.
All of
I did not
23,
understand
not just
any
that.
of it.
So, and I think, is this like on page 44? We're on the, I think that's it. So does it sound something like 524? Find an equation for the altitude, does that sound right?
Not sure.
Who knows? So find an equation for the altitude. 23.
Yeah.
No wonder it didn't sound familiar. How about a circle of radius 2? Okay, a circle of radius 2 is centered at the origin and goes through the point -1 square root of 3. -1 square root of 3. So here's a circle centered at the origin. Its radius is 2, and it's going to go through the point -1 square root of 3. So there's our point. And we want to know, first of all, can we find an equation for the line through the origin and the point -1 square root of 3? So to find an equation of a line problem. So we need 2 points, but we've got one because the origin is going to be the other one. So we're talking about the equation of this line right here.
Oh, wait, wouldn't it?
Go ahead.
If you drew a triangle,
You can draw a triangle.
then like, I guess you could use like the Pythagorean theorem to find like.
Oh, you're making it way too hard. You're making it way too hard. We need for a line, we need slope at a point.
I don't know.
Oh, this is, you can't. It's just between these 2 points, right? So y2 minus y1 over x2 minus x1 is going to be the negative square root of 3. Is that okay?
Okay.
Okay?
Yes.
And I thought you were going to go with a triangle, you could have also looked at like the right. Oh, it's weird. Rise over run. Now, we can choose either point, but let's make our life easy because one of these is the y-intercept. So now we have B and M. So it's going to be negative square root of 3 times x plus 0. And that's the answer to part A. Okay? And part B is asking us, find an equation for the line tangent to the circle at negative 1 square root of 3, and it gives you a hint. Tangent is perpendicular to the radius of the point of tangency. You didn't need that hint because you guys are all masters of geometry. And of course you remember from your geometry days, who could forget, that a radius drawn to a tangent line is perpendicular. Is that okay?
Be 1 over the square root of 3.
Okay, good. So if the slope of the radius was negative square root of 3, then the slope of our tangent line is going to be the negative reciprocal. So we're going to flip this and change the sign. That makes it 1 over square root of 3. Of course, from your Algebra 2 days, it bothers you to have a radical in the denominator. So you don't leave it that way. You rationalize it. How do we rationalize again?
Multiply by the square root of 3.
Good. So we're going to multiply top and bottom by 1 in a very strange form. So that's going to become square root of 3 over 3. So that's the slope of our tangent line. And it's got to go through that point, which we said was the negative 1 square root of 3. So, oh my gosh, do we have to find B? No, we don't. We use point slope form. Our new favorite version of a straight line. It's going to be y minus the square root of 3 is equal to the slope, square root of 3 over 3, times x minus the negative 1, which is x plus 1. And we're done, because that is an equation of the tangent line. Katrina, we okay? All right. Yeah, we good? All right, anything else?
I was confused about 27.
27. What is 27? 27 says, oh yes. So it tells us, it says, what is true about the constant beta? That funny looking B is a beta. And this is, we're trying to make you fluent in Greek by the end of the year. Following the, in the following linear equation, if its graph has the given property. So they give us, so we have talked about 3 different versions of a straight line: slope, intercept, point slope, and standard form. This is a very strange, different one. So it looks like it's y equals x over, and that's going to be beta minus 3. Does that sound right? Plus 1 over, and that's going to be a 6 minus beta. So they're telling us that this is an equation of a line. So we'll take their word for that. Beta is some number, we don't know what that is. And we're trying to figure out what that beta is if they tell us that this line is going to be perpendicular to the line y equals beta minus 7 times x minus 3. So supposedly this is a line, and it's perpendicular to that. And armed with that little bit of information, we're supposed to be able to tell what beta is. How in the world are we going to do that? Okay, well,
Wait, that's the slope.
good. So we know the slope of this line right there, because it's in y equals mx plus b
The
form.
slope of the other line would be 1 over b, or 1 over beta minus 7.
You see what, that's exactly right. You see what Aaron's saying? This is weird as it looks. This is y equals, that is m times x, and this is the b over here. So if you can look at that x over beta minus 3 and see that that is really 1 over beta minus 3 times x. Can you see it? Got to kind of separate that out in your mind. And this is the slope of the first line, and that is the slope of the second line. So we know the relationship between these is they must be negative reciprocals. So if one is a negative reciprocal of the other, What happens when you multiply them together?
That'd be 1.
Not quite 1 because of the negative reciprocal. Yeah, so if you took a number times its reciprocal, it would equal 1. But if you take a number times its negative reciprocal, it's going to be negative 1. So we can now say, okay, let's take this slope, the 1 over beta minus 3, times this slope, the beta minus 7, and that must be negative 1. Does that seem reasonable? Any nods of heads? Okay, and so now this, once we get to this, there are several ways you can do this mathematically that are correct. So I'm going to run through a couple options. How you conceptualize it now, you have some choices. You can multiply through by the denominator to cancel that. That is, you could think of as multiplying through by that denominator. That would cancel this. It would multiply it to the other side. You could make this into two fractions equal to each other, which is known as a proportion. And we know in a proportion, the cross products are equal. Does that make sense? And those are probably the two best options there. So however we think of it, we're going to get beta minus 7 is going to equal a negative beta minus 3. You okay with that? And now, let's see, that's going to be beta minus 7 equals negative beta plus 3, distributing that negative sign.
5.
Oh, you're way ahead of me.
Oh, sorry.
Adding the beta, that's 2 beta, is equal to adding that over is 10, and so you are correct. Beta is going to be 5. Okay, kind of cool? What a crazy problem. Anything else from homework?
29.
29.
From last time.
So 29. Here we go. Oh, it's kind of like an essay. Is that the one? So 29. In economics, the demand for a product is the amount of product that consumers are willing to buy at a given price. The quantity demanded of a product usually decreases as the price of the product increases. So the price goes up, people aren't as willing to buy it. Suppose that a company believes that there's a linear relationship between the demand of the product and its price. The company knows that when the price of the product is $3 per unit, so demand is going to depend on price. So demand depends on price. We okay with that? So that means our ordered pairs that we're going to go here are going to have the independent variable being the price. We can set the price to be what we want, and then we'll see how much people are willing to buy. So when the price is $3 per unit, the demand is 500 units. So we got 500. See where I'm getting that from? That was a pair. And then it says when the unit price is raised to $4, the quantity drops to 300 units. So 4 takes us down to 300. Okay, we are in that. And let D represent the quantity demand. D is a capital D, but I'm already committed to a small case D, so we'll just follow that. And we want to calculate D. So you understand where we're going with this now? I'm going to keep telling you once you figure it out, we can quit, otherwise we'll keep going. So A says, calculate demand when P is equal to 5. So P equals 5, we want to know what's the demand. And interpret the result. So should we come up with an equation of a line, because it's supposed to be linear? So we can go, I'm going to go 500 minus the 300, and then I have to go 3 minus 4. So this is going to be a negative 200 for our slope. Okay? So I'm going to say y, which is the demand, and I'm going to pick just this one, d minus 500 is going to be the slope, negative 200, times the x, which we call p, minus the 3. Okay? And then when we plug in the 5 for P, we want to know what the D is. So I'm going to add that 500. We're going to have a minus 200 times P, which is now 5 minus 3. Okay there. So that's going to be 2 times 200 is 400, so we have 500 minus 400, and that's going to be 100, and we're supposed to say units. What does that 100 represent?
From the leaders to go on 5 or?
Yeah, and it's like units. Is this like for renting something, or it doesn't even say? So 500, 100 units or whatever it is. Okay? Want me to keep going, or
No.
you got it from there? Anybody else need me to do more? Okay, so let's change gears then, and we are going to see if we can talk about lines of best fit. So we're going to go 1.6, fitting linear functions to data. So you did a little bit of this in your, I know Algebra 1 days, but I'm not sure if you did in Algebra 2 or not. Let's see, we're going to consider the data points. So consider the data points, and we're going to give you 4 of them. So we have 3, 1, and 4, 3. 6, 6, and 8, 12. So there's our 4 data points. So let's plot these, and as best we can, our lines are all going to be positive. So I'm going to do it over here, and we're going to say 3, 1 as 1, 2, 3, 1. So there's our first data point. And then we've got 4, 3, so it's going to be 4. And I'll try to make my scaling as consistent as I can. That will help our cause. 6, 6, 5, 6, 3, 4, 5, 6. Somewhere over there. And 8, 12, 7, 8, 6, 7, 8, 9, 10, 11, 12. We're playing. We'll be over here. So something like this. So the idea, once you get there, it looks like it sort of lies on a straight line, but maybe not perfectly. And that's the issue with data, is it rarely is perfect. It gets messy. And so what we want to do then is say, well, how would we get the line that best approximates that data? So what line is going to best represent what this data is doing? And so if you were just going to do it on your own, I mean, there's lots of considerations. Should you try to hit as many of these points as you can, and maybe try to do something like that? Should you try to connect the beginning and ending point? Should you try to have about the same number of points above the line as you do below? So there's lots of considerations. But fortunately, we don't have to wrestle with that too much, because statisticians have already done that. They can come up with what's known as a linear regression line, and it is our line of best fit. And so what that kind of does, in a sense, is minimize the error, the difference between the data points and our line, whatever line, the line that we're going to come up with. But we're not going to have to do this by hand. We're going to use our calculators. So we can bust those calculators out. And now the poor people that are watching the video of this may get a little bit seasick, because the best way I think I have